The title of our work is Multi-View Model-Based Visual Tracking of Deformable Linear Objects. Electrical cables, wires, and ropes are examples of deformable linear objects, a class of deformable objects characterized by a circular cross-section and a length significantly greater than the radius. These objects are present everywhere, from industries to domestic environments, yet set estimation and manipulation remains a significant challenge for robotic systems, especially in cluttered environments with occlusions. Our contribution is a novel multi-view model-based visual tracking algorithm that enables accurate and efficient 3D tracking of thin DLOs without the need for expensive or unreliable 3D sensors. This is an overview of the proposed method, combining a predictive model of the DLO behavior and a multi-view visual approach. The key highlights of our method are Cosserat rod theory, modeling the physical behavior of DLOs, a neural network-based approximation of the Cosserat model, which accelerates shape estimation for real-time tracking, 2D multi-view triangulation, which reconstructs accurate 3D shapes, avoiding unreliable 3D sensors, straightforward handling of the occlusions via the model-based approach, full state estimation of the DLO, starting from cluttered RGB images, as opposed to common state-of-the-art setups. The tracking algorithm is evaluated in real-world DLO manipulation tasks. 3 different real-world DLOs are used: red rope with a diameter of 6 mm, blue cable with a diameter of about 5 mm, red cable with a diameter of about 4 mm. The experiment comprises also 4 different trajectories and 2 scenarios with different levels of clutter. The video shows the execution of the tasks with the projected 3D DLO state overlaid to the original image frame. The experimental results are illustrated in these plots. Tracking performance remains consistently robust across a diverse set of test DLOs and scenarios, with the average distance to centerline error remaining below 1% in all cases. For more details, please refer to the main reference displayed on the slide. Thank you for your attention.